Good afternoon. So in the previous video, we spent some time in order to set up ArduPilot on our H743 Matek board. And we updated frame type, we initialized calibrate accelerometer, we set up motors, and we made sure that our motors works fine. But it's not enough to start flying, because if probably you start flying right away with no additional parameters, there is a really high probability, and I saw it too many times, that your drone can just fly out. So you can move it a little bit under the ground, and after that you add additional throttle, and suddenly it starts flying out, and with no any reactions on the sticks. And in this case, the only way for you is just disarm it to make sure that it's dropped. And always be ready to disarm your drone, especially during the first flight, because it can happen. It can happen, and if you wait too much, it can fly too far and even damage something, and obviously you can break your drone. If your drone like 5-7 meters above the ground, probably you will not damage anything at all. I did it many times, then it just flew out, and I don't remember any case, and my drone has been damaged. But in order to avoid any problems, potential problems, you probably would like to add additional parameters. And prior to play with some additional parameters, I would recommend to insert SD card in your Matek. So where is a slot for SD card? Usually you have to format your SD card for FAT32 extended FAT, and it should work fine. It should work fine. Why? In order to write some logs, and we would like to review all these logs in order to see what is going on. If you suddenly don't have SD card, it's fine. You still can tune your drone, but in this case, you just make some assumptions, and probably you will not tune some parameters like really precisely. But whatever. So what we are going to do? Last time, as I mentioned, we already picked frame type, calibrated compass, radius, provided servo output, serial ports, and all other stuff. And we even did initial tuning for our parameters using Quiz Wizard, but it's primarily low pass filter that is not doing too much. Now we are going to do some additional things. First one, we are going to modify flight modes a little bit. And what I'm using during the first flight, if you have GPS, I would recommend to have at least one flight mode loiter in order to validate GPS hold, GPS position hold mode. But in any case, usually you need to pick at least two modes. One of them stabilize and another one alt hold. Because alt hold is a very important mode if you are going to tune your drone in after tune mode. So then you just asking ArduPilot to find all needed parameters for you. You need to start flying in alt hold mode. All other modes, potentially you can use loiter mode as well, but anyway, you need to set up alt hold first to make sure that your drone is stable and can just maintain altitude. And a couple more modes that usually I set up. So I land flight mode 4 and land for flight mode 5. In this case, your drone will just land right away. You can potentially set up return to home, but just remember that return to home by default has some parameters. And one of the parameters, drone, in order to avoid any collisions, drone is going to take altitude about 30 meters right away. And it can be like really scary for people during the first flight. Then you just believe that your drone will just land or like return 10 meters left or right to the initial position, but instead it's just running up in order to reach 30 meters altitude first, and after that start moving to the best direction. It's like this mode works in this way for environments. They have huge amount of obstacles, trees, etc. So in order to avoid collisions. And the last mode that I would recommend to set up right away after tune. After tune helps us to pick PID parameters that we will do later, but prior to initiate this mode, we need to do something else. but it's worth to have it right away here to make sure that we already have a button for it, and we use 6 positional switch to pick a mode from the list. So all these modes now should be fine. In my case, I decided to add GPS in order to validate Twitter mode as well. So I can click Save Modes. I already clicked this. And after that, one more thing, fail save. Fail save, my recommendation for after tune at least, try to do nothing probably in case of a battery voltage. So usually, in my case, I'm using 6S battery, so it's like about 25.4 voltage, then it's fully charged. But if it's discharged, it's about, I believe, 20 volts. But you can see some parameters, they just can rent your drone if your voltage, in this case, drop less than 21.6, and you still have enough capacity, and it's not over discharged yet, but your drone will go and land right away. So if you start after tune mode and have land, for example, here, it means that probably after tune mode will not be completed, and your drone will be landed and you cannot control it. So my recommendation is just put none here and check battery voltage during the after tune mode. And if you can see that it's really discharged, just land and probably preserve parameters before that. And after that land, and after that tune all other parameters that were not tuned correctly yet. And it's possible to pick like what kind of parameters you would like to tune in advance. And in case of radio loss, okay, usually we can pick return to home, but for the first flight, probably it's better to enable always land, just in case of any problems with the remote control, or I don't know what can happen, but just always land. It will land right away. It's like the second settings. Third one, what we are going to do now, we are going to assume that our drone is not perfect, and it's almost true for all the drones. It's going to have some vibrations, it's going to generate some noise, and this noise can come from motors, from wires that are not fixed very well, and so on. And it means that this noise can affect our IMU sensors, and it can affect stability of our drone in general. And then we completed initial tuning parameter setup. We tried to mitigate this problem a little with low pass filter, but low pass filter allows to filter all the data in the same way on the whole interval, and it cannot select like subsets of your data in the whole interval. It just filter everything at once. And in order to have filter that works much better than low pass filter, we need to modify some settings in full parameter list. We are going to enable a thing that's called notch filter. Notch filter allows us to filter data in some small intervals, and we can define parameters of these intervals. And in ArduPilot, it can be like dynamic notch filter that will find the best interval the data should be filtered. And all what we need to do here is just enable notch filter and enable data source that notch filter will use in order to make a decision then and how data should be filtered. So what we are going to do, we are going to get information about noise using information from our ESCs. In general, RPM, rotation per minute information, but it's going to be the same information that usually we are getting using bidirectional D-shot protocol. So there are several ways. If you remember, Last time, when we defined serial ports, we discussed that there is a special cable called ESC telemetry. And for MATEC, this ESC telemetry is mapped to UART8. And this cable collect information from all four ESCs and submit to the flight controller. It's one way. Then ESC has ESC telemetry pin. All these pins, if you have like 4, 6, 8 ESCs, all these pins can be connected to a single point and submitted to like an UART on a flight controller to provide information about rotation per minute and some additional information. It's like one way. Another way, since we are using ESCs that support bidirectional DShot allows us to use the same signal cable to transfer telemetry to the flight controller. So we don't need any separate cable for that. And it makes sense, especially for big flight controllers like Pixhawk. Pixhawk does not have like any special port for ESC telemetry. You have to accommodate telemetry port for that. And usually you have 3 of them. In some cases you have 2 of them. And it can be like really costly for you to accommodate a special additional UART just to collect ESC telemetry. But if you're using bidirectional DShot, you connect your motors using signal cable to standard set of pins that Pixhawk has for motor connectivity. And if you enable bidirectional DShot, all these signal cables can be used in order to provide telemetry from your motors. So what it means? It means for us that we are going to remove ESC telemetry from this list of ports in order to avoid conflict, but instead we are going to activate bidirectional DShot. We did not do this last time, but we are going to do this now. So I'm going to go into config, full parameter list, and I'm going to pick a parameter called servo blh bdmask. It's exactly a parameter that tells which ESCs support bidirectional DShot telemetry. By default it's 0, but I'm going to modify and pick channel 1, 2, 3, and 4 since we're using pin S1, S2, S4, S3, S4 on my MATEC. All 4 channels are accommodated exactly for signals, and I'm going to use them in order to collect telemetry information as well. So what's done? And always pick right params here because it's easy to forget safe parameters into microcontroller, and after that switch to another tab, and then suddenly all changes will be lost with no warnings or anything like this. It's like first change that we have to do if you're talking about bidirectional DShot. The second thing that probably I forgot to tell you last time, in ArduPilot, especially for people who are flying in Betafly, in ArduPilot, if you use pitch stick, usually in Betafly, if you move the stick to forward direction, to the top, your drone is going to have inclination and start moving forward. If you're moving stick to yourself, your drone is going to move to the same direction. But in ArduPilot, direction is different for any kind of reason. And if you move the stick towards to yourself, your drone will go to opposite direction. And the same if you're moving stick out of yourself, your drone will go towards to you. And it's a problem for the first fly. Usually it can scare people. So that's why we need to modify a channel. Let me see which one. So for pitch, we have channel 2. And by default, it's RC2. Let's go to parameter list and type RC2 here. And we can see that there is an option called RC2 reversed. By default, it's like normal. So drone will behave strange. Probably for fixing planes it works fine, but for drones it doesn't work well. So I'm going to pick reversed here. Okay, now after we modified bidirectional D-shot parameter, after we modified stick, what else? We modified flight modes, we modified serial ports, removed ESC telemetry here, checked fail safe. We are ready to enable notch filter, and we will be ready for the first flight after that. So you can just go and enable notch filters. But if you would like to review data after your first flight, it will be worth to log everything that is related to notch filters as well. So usually we have to set up several log parameters. And first of all, we have to look at log bit mask and pick several important things here. Usually you can log everything rather than raw IMU too much. We are going to log them in batches, and plus it's good enough to have fast IMU, and we can pick everything rather than raw IMU. Video stabilization, we don't have video stabilization, we don't have optical flow, we don't have camera at least connected to ArduPilot. We don't care much about navigation tuning. We don't care much about control tuning as well, mission command, but I'm going to leave everything. It's going to be like not too much. To log, why I deselected raw MU, for example, because log is going to be bigger, and it means that we'll spend more time to download it. And I'm going to close this window. After that, I need to one more thing for logging, and here I'm going to use parameter that has name ins log bat opt. This is a login parameter for filters as well. It allows us to log data and separate them for pre and post filter processing. It means that we are able to compare results. Then filter had not been applied yet, and then filter already has been applied. And we are going to log everything in sensor rate. So we picked these two parameters, and we can close this one. And one more, we have several IMUs. Even on Matek, I believe we have two IMUs. I'm going to log information just for first one to reduce number of information in the log, and probably it can affect speed as well. So these three login parameters I'm going to leave here. Okay. And we need to do reboot. So I'm going to go to compass as usual. In my case, I don't have compass. We'll just remove them later, but I picked another drone. Last time we removed them, but for now I have one more again. And I have GPS, so I will need to initialize everything a little bit later, but not for this video. Okay, we restarted our ArduPilot. For any kind of reason, it took much time. And if you don't like full parameter list, potentially, it's connected. Potentially, you can go into optional hardware, pick FFT setup, and play with login parameters here. But it doesn't allow you to pick that ins bat log that we asked to log pre and post processing filter information. But here you can just modify logs. So we can go back to the full parameter list. One more thing that I'm going to check. Last time I applied some changes to armin pre-check. So usually here I'm leaving barometer. I will add GPS as well here. I'm leaving RC channel availability. We can talk about battery. And once you have obviously system, and that's all. And once we have GPS, we can pick GPS configuration, GPS lock in order to successfully arm our drone. This is the final set of parameters that I'm going to have here prior to the first flight. And filters, finally. So what I'm going to do, I'm going to pick parameter that called ins_h. You can see ins_h notch enable. Right now, we don't have any notch filters, and it can be a problem. It can be a problem because your frame will definitely generate some noise, and if you don't enable them, your drone can behave, as I mentioned, you cannot predict behavior of your drone. It can just fly away. So what I'm going to do, I'm going to enable these filters, and I'm going to write parameters. Okay, and once you do this, you will be able to see some additional parameters here. So what kind of parameters we are going to modify? First of all, we are going to modify ins_h notch reference. By default, it's 0, but we need to put 1 according to, frankly speaking, this description that tells us to change this parameter if you are going to get information about for notch filter from AC telemetry. We are going to do exactly this. Next one, I am going to, don't touch this one as for now. I am going to pick mode of the notch filter. Mode can be different. You can specify a frequency where notch filter can work, or you can potentially implement notch filter based on your throttle position. None of them is usable for quadcopters. All of them usually are useful for fixed-wing drones. After that, we have several useful things. First of all, RPM sensor. RPM sensor, usually pick it if you have RPM sensor on your motor. I know several motors that have Hall sensor or anything like this, and you can get information from those sensors directly. And usually it's like really precise, really accurate. But we are not using motors that have these sensors usually because they're very expensive. But another way is enable AC telemetry. So once you have bidirectional D-shot or AC telemetry as a separate wire connected to your ARC, you can pick AC telemetry. For any kind of reason, if you don't have bidirectional D-shot, you don't have AC telemetry, you don't have RPM sensor, you have nothing, you always can pick dynamic FFT. It's fast Fourier transformation. It's last resort. You have to do it just in case if you don't have any other options. This is a very algorithm that affects your performance very well from that perspective, obviously. And for H743 microcontroller, usually good enough, but obviously these two options, especially AC telemetry, does not require so much power. So we are going to pick AC telemetry here. And after that, we are going to set up filter itself. Usually 3 harmonics are good enough. So I'm going to pick third harmonic here and close this window. And this is our settings. After that, there are some additional settings like frequency. There it's going to start implement notch filters like center frequency. Usually we're not picking it because it's in our case, based on AC telemetry, is going to be probably dynamic. So we will try to just don't touch it, and I hope that it will just pick the best central frequency for each interval. So should be fine. And you can see where is a comment. This is the central frequency for static notches. We don't have static notches, we have dynamic notches, but whatever, throttle based, we don't have throttle based. And there is One more thing called H-notch BW. Usually it's a bandwidth. It's an interval. There your notch filter is going to work, and there are several intervals like this, and this parameter should be picked based on your observation. And by default, usually it's half of your frequency, but it's dynamic frequency, so what does mean half of it? And there are several recommendations, and from time to time I followed these recommendations, but I found that they are not very effective. For example, there is one more parameter called option, and option allows us to do something else. First of all, we can specify that we would like to update our filter using loop rate in our microcontroller. And the second, there is this very important parameter, multi-source. What does mean multi-source? In order to filter data, microcontroller taking AC telemetry information from all four motors, and after that calculate average. And it can be not very precise if your motors has like some problems and work differently. If you set up multi-source, it will enable notch filter separately for every motor. So obviously it can affect your microcontroller, but as I mentioned for H743, it works fine. And there are some recommendations that if you have bandwidth 40, for example, here, and central frequency about 80 GHz, it will be great to reduce bandwidth if you pick multi-source and use 20, for example. How it's calculated, central frequency divided by number of motors, and you will have 20. It never worked for me. First of all, as I mentioned, probably this parameter is not going to be used at all. And the second, I found, especially for drones that I'm building, that bandwidth like 40 works much better in multi-source for my drones rather than 20. But I'm going to show how to validate it and how you will be able to see which bandwidth finally to pick and should you enable multi-source or not. Initially, you can even leave multi-source unchecked to reduce requirements, to reduce overhead for your microcontroller. But later you will be able to open your logs and you will be able to see if multi-source can be useful if you enable it later. In my case, I'm going to leave it because I know that it works better for my for my drone design, and I'm going to write parameters, but I'm going to show what is going to be different. So once again, we have to restart our drone. I'm going to compass, where is compass, and click reboot here. Once again, and I hope it's not going to take much time now. No, it's still like when you kind of listen, I read too much parameters. And next thing that we are going to do, I strongly believe that it's not needed, but some people believe that it can be important. We already specified bidirectional G-shot. We already specified which motors are going to be used as source for bidirectional G-shot. We already specified notch filter parameter that tells us pick AC telemetry, and it should recognize that, okay, I'm going to pick AC telemetry using bidirectional G-shot because AC telemetry pin is not initiated for us. I removed AC telemetry yard. But some people believe that one more parameter should be set as well. It's called RPM1 type. This parameter allows us to set up RPM library internally in ArduPilot if it's really needed. If it's affect anything, I don't know. I need to check code. Probably you can do this, but lots of people tell that this parameter is very important. So we are not going to risk. We are going to just set up this parameter. RPM type allows us to set up RPM library that allows us to calculate rotation per minutes based on telemetry that we are getting from bidirectional shot, and it can be like a source for our notch filter. So what I'm going to do, I'm going to pick just AC telemetry motors bit mask. Take AC telemetry based on motor bit masks. That's all what I'm going to do. And it's how like we have to set up it. I'm going to write parameters, and it's going to add a few more parameters right away. So you can see that there are some parameters that probably you don't want to touch at all, but one of them you still can modify. You can modify which channels you're going to use in order to collect ESP RPM telemetry data. As I mentioned, I strongly believe that it's happening automatically, but I don't want to check, and it's really hard to prove. So done. And at this point, we are not going to do anything. I would just remind you that there are a few parameters that they initiated. Then we did initial tune as well, and some of these parameters, first of them, it's a learn parameter. Learn, where is it? Well, this one, mod Harvey learn allows us to get information. So flight controller will be able to check which throttle or what is the throttle position, what is the thrust needed in order to have stable Harvey. And at the end of your flight, in alt hold mode, it's going to calculate this value and save it, updating a parameter that called, let's see how it's called. It should be motor thrust Harvey. You can see by default, it set parameter into 0.2. And for many drones, it's a small parameter. For my drone, it's going to be big because I have very powerful motors, and we'll be able to see what will happen to my drone once we'll start learning or at least execute our drone in alt hold mode. So as for now, my drone is ready for the first flight. And what I'm going to do, I'm going to just arm it, move a little bit up, see if I have any kind of oscillations, and after that switch my drone into alt hold mode if I don't have too much oscillations, and see how it would behave in alt hold. Let's see. Okay, you saw that during the first part of the flight, the drone was pretty stable. And frankly speaking, I'm very disappointed because usually I can see oscillations. So in this case, for any kind of reason, drone did not want to oscillate, it just flew very well. Not well, but not bad. So if you see oscillations at this point of time, even prior to switch to alt hold, because I started flying in stabilized mode, what you're going to do, you're going to go into parameters to origin. You're going to go into config and you're going to modify tuning parameters. Usually, if your drone is accelerating, modify pitch, at least row and pitch, just decrease all parameters, at least first three parameters, P, I, and D into times. And alternatively, you can go into basic tuning mode and just move this roller, in this case, to, for example, 0.07. And oscillations should go away. And your drone probably can be a little bit raggy, but it's not going to fall and it's not going to do anything strange. Yeah, so you will be able to start tuning. But after that, I switched my drone into alt hold mode. And you were able to see all these oscillations. Shoo, 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 shoo. So it's great that we have at least oscillations for alt hold. Why it's happening? Because default parameter that I showed to you, 0.2 for my drone is too big, and there is another parameter. It's too big, but from one perspective, and ArduPilot assumed that it's going to learn it and probably increase, but there are two more parameters. Where is it? If you go to extended tuning, you can see there is a section called throttle accelerometer. There are two more parameters, P and I. And there are recommendations for P and I. Then we completed initial tuning settings. It was recommendation change P, set it equal to hardware motor thrust. And in my case, right now it's 0.2 and it's too big, and P is much bigger than 0.2. And change I, like just increase it into times smaller than thrust. And it should be not more probably, or 0.4, but now it's 1. And these parameters just add much acceleration to my drone. So in order to remove acceleration, what I'm going to do? First of all, I'm going to look at logs. How I'm going to do this? I'm going to go to data, and if you use this button, you can go to the last tab. It's called data flash logs. You can click download logs, and there are some logs on my SD card. You can just download latest log from your experiment. And once you have your log, you can close your window. I already downloaded it, and you can review a log directly from here. So I'm going to pick my log from here, and right for now, I'm going to check hardware thrust for my drone, and it can be done using CTune category set of parameters. I'm going to expand it CTune, and I'm going to pick two parameters, throttle O and throttle H. And you can see this is my value that I have in parameters right now, 0.2 from one perspective. And this looks like that my real throttle hardware parameter, that it's about 0.08, even less than 0.1. And you can see all these oscillations here. So even if you have a little bit bigger default parameter, you should not have oscillations here if you have P and I correctly set up. But in my case, I have big parameter here, and P and I are incorrectly initialized as well. So what I'm going to do, I am going to try use this medium value, and you can put the minimum parameter. Minimal for total hardware is 0.125, and after that, and at the same time, you can decrease parameters P and I. So let's do like this. What I'm going to do, I'm going to go to config, full parameter list, and first thing that I'm going to modify, I'm going to modify motor. You can see from time to time you can have duplicates here. If you have duplicates, you can just click refresh params. Okay, you don't have duplicates anymore. And I would like to pick 1 to 5. Officially, it's the minimum value for motor trust hardware. If you try to put something like this, it tells that it's out of range. I will leave it to 1 to 5 now, but later we will reduce it and I will explain what is the difference. And I'm going to write these parameters. And after that, I'm going to go into extend tuning and reduce P and I. And let's do P. Minimum value for P is 0.2. Let's leave as is. And let's have I 0.3, for example. It's even 25. It's exactly in 2 times more than our existing thrust hardware parameter. But I'm going to write this stuff into config, and let's try to fly again, and let's see if it's going to change anything. So I just started my drone in stabilize mode, and after that I switched into alt hold mode. And you can see that now I don't have oscillations anymore because I put like initial motor hardware trust parameter or total parameter, whatever, into minimum value, and I reduce P and I at the same time. But you can see that it's pretty stable, but it's about 0.075. And at the same time, my value that I set up, it was 0.125. And it's like too far from real value. That's why what I'm going to do, I'm going to set up exactly this value that I have here. So how I'm going to do this, I'm going to close my org, go to config, and go to full parameter list and open motor category here. And first important thing, I need to remove motor hardware learn, because if I change parameter right now to something smaller than 0.125, it's going to modify it back to this minimum during my next flight. This is something I don't want to see. So I'm going to disable learning, and now I can modify this one to 0.75. Sorry, 0.075 or something like this. It tells me that it's out of range, but in fact it's going to work like this. And moreover, in comments, it tells that it should be between 0 and 1. It's exactly between 0 and 1. Everything is fine, and now I'm going to write these parameters. And since my motor trust hardware is pretty small, I even can modify P and I, or I can leave them small enough because it looks like that they are working fine right now, and my drone can does not provide any oscillations, and I tested it in like real alt hold mode, and it looks like that it can maintain the altitude. That is really great, and for me it means that now then my drone is not oscillating, and when my drone can maintain alt hold mode, be very careful in alt hold, because in alt hold then you have throttle stick up, in the middle from 40% up to 60%, your drone is going to do nothing. It's going to go up if your stick more than 60%. It's going to down if your stick is more than less than 40%. So it's like a little bit different behavior compared to stabilized mode. But since everything works fine, I am ready to set up PID parameters. We did not touch PID. I just mentioned that if your drone is accelerating, just reduce rate and roll and pitch. But as for now, they are too big for my drone. And in order to correct them, I have several options, and one of them is after tune. If you are able to run after tune, just wait until your drone set up all the parameters. It's probably going to be not very bad decision. If you're capable enough to modify these parameters according to the documentation, see then your drone is accelerating, and after that reduce them and so on. Okay, you can do this. Probably I will demonstrate this in the next video, but after tune video you already have on the channel. So anyway, I'm ready for after tune. I'm ready for after tune. The only thing that I still would like to demonstrate is filters, because we set up filters and we need to make sure if our filters really work. Yeah. So what I'm going to do, I'm going to open browser and I'm going to open a page called firmware.ardupilot.org tools, web tools. And there are a bunch of tools that are very useful. And that's exactly why we collected all these logs. We are going to use two tools. First of all, filter review tool, and the second PID review tool. PID review tool we are going to use after tune and probably for manual tuning of our PIDs. But filter review is something we can use right now. So we just go inside into the tool. You can do the same. You can choose a log file. Usually you can find them in documents. Mission planner. Where is mission planner? This one, mission planner, logs, quadrotor, and this log, for example. So here we just checked. We can check our throttle flight data, even 0.07, even less, but I believe 75 should be something that will work fine for us. But what is more important, data that had been collected, like pre-filter and post-filter based on our notch settings. And if we remove post-filter data, just click here on the title, you will be able to see few spikes. And for experts, usually experts tell that everything that is greater than minus 50, so this peak, this one spike, are not good, really bad. But if we turn filters on, let's remove initial data, you will be able to see that all the data starting from like 50 Hz, it's exactly where we have to look at, they are less than minus 50 decibels. And if we switch the graph into linear mode, you can see that it almost does not have, it has something here, not very critical. And if you compare to like original data, you can see in linear mode, much bigger spikes, exactly our noise. And we can see that notch filter worked fine. And for this experiment, I believe that we have to do nothing. Yeah. So for this experiment, I recorded with multi-source. Okay. But what you can do if you are not sure about should you enable multi-source or not, what you can do, you can potentially enable, or in this case, so it's disable multi-source here. And you can modify other parameters. You can modify bandwidth, for example, and click recalculate filters. And it recalculates everything based on pre-filtered data, apply filters, apply updated parameters, and you can display them clicking estimated post-filter one. And you can compare if it's going to be better or not. Um, you can see that almost no changes. Let's go to decibels. I believe that as for me, even yeah, we turned off multi-source, and we can see that once we turned off multi-source, uh, the whole graph moved, for example, with peak to high frequency. That is not good. So yes, multi-source works better than we apply notch filter to every motor rather than doing average of them, but not critical in both cases since it's less than minus 50 decibels in any case. But yes, in this case, you can see difference. In some cases, I can see that, and it's more like linear, yeah, so less fluctuations if you, but it's not for multi-source, whatever. But usually, if you still, even after notch filtering, can see spikes, it does not look very well. You always can do this trick. You can just go to settings, filter configuration settings, turn off or turn on additional harmonics. And in some cases, you can see that, for example, you don't need second or third harmonic. It works well, yeah. So don't overload your microcontroller. Update parameters, update bandwidth, and see what is going to happen. Just click recalculate, and after that, display and compare. So it's useful if you have problems even after notch filtering. But usually in 90% of cases, I have at least one drone that does not work like with all the default settings. But in 90% of cases, default settings will work fine for you, and you have to do nothing. And that's all. That's all. And one more thing that worth to check data from your AC RPM, if we really collect this data or not. To do this, I still need to go into data log, click review log, pick my log, and go to ESC. And you can see my ESC and RPM. And you can see if you see graph like this, everything looks fine. So the same for second ESC, third ESC, and last one. If you don't see a graph like this for any particular ESC, I had this problem yesterday for one of the drone. It just it suddenly dropped, decided to drop into the snow, and I thought that I got a problem with ESC. And it can be a problem with ESC itself, and for any kind of reason, it's not operational. It does not, and usually you can see this your motor is not spinning well or not spinning at all. Or it can be a problem with your flight controller. In my case, yesterday I got a problem with flight controller. It worked well, but after the snow, it was probably really high humidity or anything like this, and I did not apply a special solution to make it a little bit waterproof at waterproof capabilities. I found that one of the motor pin is not working properly anymore. Flight controller works well, but looks like that I need to modify, redirect my ESC to another motor pin and modify configuration. And it happened to me yesterday. And using this graph, you can see if your G-Shot works well for all the motors, and if it does not work, check ESC or check flight controller itself. But right now we have all four motors are fully operational, and all four ESCs return information about RPMs. So everything looks fine. Looks fine, and at this point, that's all. Later, obviously, after June, we will need to review additional works and see how our PID are doing. And we probably need to manually configure or adjust some parameters. But at this point, you should be able to have you should have a drone that should be able to fly, uh, work, be stable in delta hold mode, and right after that, you can run after tune. Because if your drone is not able to maintain altitude and oscillating, it means that after tune will not work at all. The drone probably will drop right away. So, and you have all parameters are in place to initiate after tune process. If you watch my previous videos about how to set up 6-positional switch and how to do initial settings, and I already published a video for this drone about how to do after tune. It's a boring video, but it's on my channel. And that's all. Thank you.